Today's presenter is Lucidworks Senior Engineer and Lucene Solr Committer Tim Potter. Thanks for joining us today, Tim.
Thank you, Aaliyah, and welcome everyone. Before I get started, I'd actually like to mention that the Lucene Solr Revolution Conference is almost upon us. It's happening this year in October in Austin, which is a great time to visit Austin, actually. So if you haven't been, we hope you definitely come out there and try to learn about Lucene and Solr. And if you've been there before, it's a great conference, and we hope to see you out there again. So today, I'm going to talk about a couple technologies and actually how they integrate that I'm pretty passionate about and actually get to work on here at Lucidworks, which is Spark and Solr. So I'll probably start with a little Spark overview. And so if you're familiar with Spark, this will probably be a little bit of a review. But for those that are new to Spark, I think it's important to kind of get the sense for why Spark is exciting and some of the important concepts in Spark, such as resilient distributed data sets. And then I'll actually get into some of the sort of interfaces where Spark and Solr integrate, such as how to query Solr from Spark and how to index data into Solr from Spark. And then I'll probably wrap up with a discussion of sort of how we use Spark in Fusion, and then we'll definitely leave time for questions at the end. So a brief bit about me. I won't spend a lot of time here on this slide, but I've been working with Solr for about 5, maybe 6 years now, around 2010, and then Lucene for a little bit before that. And then I actually became a committer last year in 2014 and a PMC member this year. And I've, for the most part, focused on Solr Cloud and the distributed scalability features around Solr. I also wrote bin Solr, so hopefully you got to check that out and see what a nice experience it is for using Solr. I also was the co-author of Solr in Action, and in addition to Solr, I have sort of a big data background around Hadoop and Zookeeper and those type of technologies, and I have been working with Spark for about a year now. So Solr, just for those of you, I'm sure most people on the call are actually very familiar with Solr, but it's definitely worth taking a look at because we've been doing some really exciting things in the Solr 5 release line, which is the active one now. We just released Solr 5.3. The open source community itself is as vibrant and thriving as I've ever seen it. The contributions coming in are just amazing, from outside to just beyond committers, and continues to get stronger and stronger. We recently added security and authorization framework. I worked on some things to improve indexing performance. We've been adding things like for doing different sort of distributed cardinality estimation with hyperlog, and to me the getting it started experience around Solr has just gotten to be really strong in version 5. So definitely take a look at the 5 line if you haven't. And then also we're doing some things around like making sure that Solr is sort of a good participant in the Hadoop ecosystem, such as being able to run a Solr cluster on Yarn using a technology called Slider. Okay, so Spark, I don't want to try to do a whole feature survey of Spark because there's actually a wealth of really good information on getting started on the web. You can just go to the Spark website on Apache, start there. There's some great documentation and tutorials. For those that are a little bit more technically inclined, I highly recommend the original paper on Spark that came out of Berkeley. Really covers a lot of the core concepts and thinking behind Spark. For the most part, you can sort of see Spark as a sort of modernized alternative to MapReduce, although it does a lot more things than just MapReduce. But one of the key aspects of Spark, and I think that's why it's garnered a lot of attention lately, is that it is really fast. For example, Spark running on Hadoop sorted 100 terabytes in 23 minutes. And that was actually 3 times faster than the previous record, and actually used nearly 10x less computing power. So that's very powerful and speaks to some of the hype around Spark is actually very justified. The other thing I really like about Spark, and as I mentioned on my intro slide, that I've actually done a lot of work with Hadoop, Hive, and Pig and these things, and Spark took the approach of rather than kind of having all these additional technologies to make up for the shortcomings of MapReduce hanging off the Hadoop stack is just to build a unified big data platform. And we'll see some examples of that later in the discussion. But that's really what Spark is striving for, is to make it so that you can do all of your big data computing tasks in one platform that's familiar. And I think Spark does a pretty good job of that. Obviously, it's still maturing itself, but it's doing a good job so far. One of the things also that's very cool is that you can write Spark code with Java. Myself, I mostly do Java, but you can also use Scala, and we'll see some examples of using Scala, which is a little bit more of a functional type language. And some of the things you do in Spark are very functional in nature. You can also use Python, and it didn't make this list. The slide's a little old, but now you can actually use R to interface with a Spark cluster. So that's very cool. Myself, I'm not an R programmer, but for the R people out there, it's actually pretty awesome to be able to actually compute some expensive statistical calculations on a Spark cluster using R. The other thing that's quite interesting about Spark in my mind is that you have a lot of options on the actual cluster technology that it runs on. It has its own out-of-the-box standalone clustering distribution technology, but it also runs nicely on Yarn or Mesos. And one of the things that Spark knew they had to integrate well with was HDFS. So here, I drew up this slide because it kind of helps me make sense of the various moving parts in Spark. And as you can see, that there actually are a number of components. As I mentioned on top, there are various languages. So you know, if you're a Python person, you can actually download Spark and immediately start using Python to interact with it, which is quite cool. Below that are these main components of Spark. There's Spark SQL. There's the Spark Streaming, which I'll actually talk a bit about Spark SQL and Spark Streaming throughout the talk and give some examples. There's also the MLlib, which is where they're doing things like logistic regression and those type of things with Spark. And then there's also a technology in Spark called GraphX, which is your more iterative graph type algorithms that use sort of a bulk synchronous processing type programming model. Below that is really the Spark engine. And as I mentioned, Spark was able to break that sort terabyte, so the 100 terabyte sort record on Hadoop because of this Spark core. And the Spark team themselves have really done an excellent job of coming up with a way to compute on a distributed cluster very efficiently. And so when you do things like sorting by keys or reducing a job by a key, that invokes what we typically call in the big data world the shuffle. And so a lot of what's in the Spark core is optimization around the shuffle and being very smart about that and actually using the network libraries very efficiently, like zero copy techniques and things like that. The other thing that Spark, and if you've probably heard anything about Spark, it's that it's an in-memory computation framework. Well, what that means is that actually they do a really good job at keeping data that needs to be accessed frequently and most recently in caching. Because obviously if you have a job that takes 100 terabytes of data, you probably don't have 100 terabytes of RAM. If you do, I'd love to talk to you. But the point being is that Spark does a really good job at optimizing memory access. A newer one is this Tachyon framework that they're adding, and that's more like if a job needs to share data that's in memory, Tachyon allows you to do that very efficiently in a distributed fashion. And then, as I mentioned, Spark runs very nicely on either Hadoop, Yarn, Mesos, or its own standalone technology. Okay, so physical architecture. This slide I was really more for reference, but one thing that in my mind stands out is that every Spark app, you bundle into a jar, and then you basically create in that app a Spark context, which is really called the driver. And that driver is responsible for essentially computing this sort of logical plan for executing a job. And then it works with the Spark master and the workers out in the cluster to actually get the task scheduled. And every Spark app will have a job. The tasks for that job will be executed out on the worker nodes in a Spark executor. So there's a new executor for every job, which is quite different than MapReduce, because MapReduce actually fires up a whole new JVM process for every task. Whereas with Spark, the job essentially gets the executor and tasks are then executed within that process. So that's a little bit different, and that's another way that Spark is a little bit more efficient in how it executes tasks in a distributed cluster. So if we look at Spark versus sort of Hadoop's MapReduce, obviously the main programming construct in MapReduce is the MapReduce paradigm. And for doing data manipulation, people have become, very, very clever, such as those that created Pig, created all these awesome data flow constructs on top of MapReduce, hiding that from you. The key here is that Spark, coming after Hadoop, was able to basically see these evolutions in the Hadoop ecosystem and really kind of build in common data manipulation things, such as grouping by keys and mapping data to different data structures, projections, and whatnot, doing counts and distincts and tops and co-groups, all the kind of relational things that data analytics people want to do on their data are now more built in and optimized in Spark. Whereas with Hadoop, it was always some add-on technology such as Pig or Hive to really kind of hide the MapReduce underpinnings. Well, that actually ended up being really inefficient. And so a lot of what Spark, the benefits of Spark on top of Hadoop is that it really overcomes a lot of those limitations around MapReduce. So the other thing I think that we'll talk about shortly is that Spark achieves fault tolerance very differently than Hadoop does. But first, before we really get into that, and this will be a good segue into it, let's walk through what would sort of be called the hello world of big data, right? And that's word count. We want to count, across terabytes of words or whatever. And so really, again, as I mentioned, Spark allows you to write code in Scala, and this is an example of Scala. If you don't know Scala, that's no big deal. I think you can actually look at this and really basically see what it's doing. The first step is that we tell Spark, hey, we're going to load some data out of a text file. We're giving it an HDFS URL. Well, that text file is obviously split up into blocks around the HDFS cluster, and so immediately we already have sort of a distributed problem because this text file is so huge, it's not on one machine, it's out in HDFS. And so Spark handles all of that. As I mentioned before, HDFS is a first-class citizen in Spark. So if your data is already in HDFS, you don't have to, basically lose any of that or change it to a different format. Spark already works with data in HDFS very well. The next thing is some functional code that is essentially taking the lines in that Spark text file, and it's mapping essentially the lines. It's splitting up these lines by white space there into words. And then what that does is flow into another function, which is this map function. And we're going to take each word coming out of the line split, and we're going to actually map it to a little tuple there, which is the word itself plus an integer 1. And then we know that with word count, all you do is essentially reduce all the same words so that you send them all to the same reducer, and then you add up the counts. In this case, we're adding up the 1, so we're reducing by key. And Spark sort of builds that in very nicely with this Scala function. Finally, the output, which is our counts, our word counts, we save it out to HDFS. Excuse me for that. So let's actually walk through how this happens in Spark, because I think it really helps you get a sense of how the Spark logic works, and then that'll lead into fault tolerance and a key thing which is called an RDD in Spark. So again, the first step was we're reading data from HDFS. It's distributed around the cluster in these various partitions. Flat map, all we're actually doing here is we're applying a function to the data we already have loaded. And so there's really no network traffic or anything like that. All this happens in the memory. And what we're doing is we're breaking each sentence, if you will, by white space into individual terms, right? And that function happens in memory. In Spark, essentially a lot of the computation a lot of the parts in Spark is figuring out when they need to cross network boundaries and when they don't, and it optimizes the job around those stages, if you will. And then remember, we then mapped, which map is a simple function that essentially takes a data in one form and turns it into another form. And here we've turned it into a pair, a key value pair of the term and then the actual integer 1, which we'll use to sum up later. And then effectively, Spark knows where all these partitions live in Hadoop because that's what HDFS gives you. So it'll schedule tasks out close to that data. That's the data locality that we're actually, we've come to expect from Hadoop. And, one of the more powerful things of the Hadoop technology is data locality, and you move your computation to where the data resides. So all this, again, happens in a data local, hopefully, executor that's reading, off local disk through HDFS. So that all works really well. The final step, of course, if we remember, is this whole reduce by key. So we're going to effectively count up all the occurrences in my example here of the word quick. There are 3. And because we're doing a reduce, we have to shuffle across the network, right? And again, Spark has done a very good job at sort of optimizing that shuffle layer. Okay? And so we send each key to its own reducer and come up with word counts. That's the classic word count. So this slide could really apply to MapReduce because it's very much the same thing until you get into the question of fault tolerance. One of the key points about big data and all of this is I don't want to have a job that runs for hours and then has one minor blip, whole job crashes, and I have to start over, right? One of the powerful things of Hadoop and MapReduce was that essentially the job tracker could keep track of which tasks crashed and just restart those and retry. I apologize. So what happens in our example if the purple part here, for whatever reason, disk failure, what have you, crashes? What Spark has to do is Spark actually has to basically decide, I need to recompute just that partition there. And so it uses this concept of what's called an RDD. Let's go through that. So in Spark, an RDD is essentially this read-only partition collection of records. And the whole read-only immutable thing comes really from its functional underpinnings in Spark, is that essentially every RDD, once created, and cannot be changed, right? And so RDD is either created from an external system, in our case, in this example, is HDFS, and a text file HDFS, or it's a transformation from another RDD using one of the operations I mentioned, maps, joins, filters, those type of things. And so what RDDs do is rather than keeping copies of the data as it flows through the system, we already know the data is not changing. So meaning the RDD itself can't mutate. So Spark simply keeps track of the lineage of transformations made to that data. And so what happens is if partition is lost in the RDD, Spark knows how it got there and can actually just go back and replay. And the nice thing is that in some jobs, for example, when you're computing PageRank, is very iterative. You can get to RDDs in a state where it was very expensive to get to that point. And when you get to that point, if you lost a partition, it would be very expensive to recompute it. So Spark actually gives the developers tools, ways to tell the Spark framework that it was quite expensive for me to get to this RDD state, so I want to go ahead and persist it in case the job fails, I can restart from where I persisted it, such as like a checkpoint versus actually having to go all the way back at the beginning. So that's a tool that Spark gives to developers to kind of give hints to the framework for that type of thing. And then also, as I mentioned, RDDs are partitioned. They are distributed around the cluster using some partitioning scheme. And the user yourself, you can actually control the partitioning scheme. And we'll see an example of that actually when we start talking about Solr. Okay, so let's get into the Solr aspects. And I think the most interesting, or one of the most interesting areas of where Spark and Solr interact, actually exposing Solr as a Spark SQL DataSource. So pretty recently, I think it was around Spark 1.3, the Spark team introduced this idea of a data frame. And if you have a background with pandas and R and these things, the data frame term should seem familiar. What it really is sort of a, it's a DSL, it's a smart data structure for actually, working with structured data that has a schema. And so Spark's really just kind of built off that idea and said, well, we'll have a data frame. Obviously, it's backed by, big distributed cluster. And a data frame itself can come from any number of sources, Solr being one of those. It could be Hive, it could be JDBC, Cassandra, any number of these popular systems that are actually now exposing themselves as a SQL data source for Spark. And so let's take a look, actually, example, this code here at the bottom. You don't have to read it and try to understand it too much. The key line is this data frame, df equals SQL context, yada, yada, yada. The key there is that you basically just say to the SQL context, which is a Spark object, you say, I want to read data in the Solr format with some options. And the options are obviously going to be data source specific. In this case, Solr, Zookeeper, host, and collection. If you're a Solr person, those should look very familiar. If not, Solr uses Zookeeper to sort of manage cluster state and cluster metadata. Then collection, in this example, I'm calling it tweets, and we'll work with the Twitter example throughout the slides here. Once I've loaded that data frame, I now have a number of different data manipulation type operations. In this example, I'm essentially getting a count of echoes. Presumably those are retweets in Twitter. So the key with Solr as a SQL data source is now it makes it so that Solr is just another data source that you as a Spark user can call up on demand very easily using a standard API and start reading data out of Solr. Okay, and one of the other things that Spark SQL does, and you might have guessed it by the name, is that actually Spark SQL allows you to formulate SQL statements against these data sets. That's actually very powerful because now you can see perhaps you have a data analytics problem where you have some data in Spark, maybe there's some smaller metadata in a Postgres database that you want to access through JDBC, and then there's some data in Solr, and you want to join all that together and do some various analytics on that data. With Spark SQL, you effectively create a data frame for each data source using this common API, as we're seeing here. You can register it as a temp table, so now it looks like a relational table to Spark SQL, and you can start to do SQL analytics across multiple data sources in one thing. And that's very powerful. The other thing that's actually very cool about Spark SQL is that it allows you to use Python or R. There's no native R interface for Solr that I'm aware of, or, as an open source project. But using Spark SQL and the Solr as a SQL data source, you can actually just fire up R and read in an R data frame using the similar syntax of Solr, and then start interacting with your Solr data from R. So of course, the API for Spark SQL is actually quite easy, as we saw there. But what happens under the scenes is what I want to talk a little bit about, because that was actually the work we had to do at Lucidworks to make all this work. And the first thing is really, when you're reading data out of Solr, Solr is a very powerful query language. So for the most part, you could, by default, just read all data in a collection. But most of the time, people actually have an idea of the data they want to pull out of Solr. So you can really execute any Solr query with all the power of Solr behind you and expose that essentially as an RDD in Spark. And again, the RDD is that core data structure in Spark that it manages. And if you're thinking, if you remember my talk about fault tolerance, if one of the partitions of the Solr RDD goes down, then Spark will have to go back and query a specific shard, for example, of your collection to recreate that data. So again, the RDD concept extends all the way into Solr with this stuff. The other thing, though, is actually you're probably not using Spark and all this power if you have small data. So usually you're actually going into Solr and you're pulling out large amounts of data. And so the Solr RDD implementation uses what's called deep paging cursors. And that allows you to go very deep, but in sort of a streaming, sort of stepwise paged fashion, very efficiently using cursor marks. And there's a great blog by one of my colleagues, Hassman, about cursor marks. He did that work, and it makes it very, very efficient to go deep in and do, read millions of rows out of Solr. The other thing that the actual Solr RDD does, which is to stream documents from Solr. So instead of, the typical search engine use case is that a user will send a query and the results will come back, in like maybe 10 or 15 results, and then, maybe go to the next page, but that's very rare. With this stuff, you really want to start receiving docs as quickly as they're identified. And so there's some things built into Solr to make it very efficiently to start reading larger result sets very quickly out of Solr. And so the RDD takes advantage of a lot of those things. One of the key points is with this is that by default, we have in Solr, we already have a natural partitioning scheme. That's the shards on a collection. So when you set up a collection in Fusion or Solr, you set up the number of shards. And usually that's based on around kind of an idea of how much data you have and things like that. Maybe you want 50 million documents per shard. You have 500 million documents, so you probably have 10 shards or something like that. So the RDD framework can go into Zookeeper and determine how many shards are available into this collection. And then when you execute a query to load that data, what happens is actually we partition out and create a Spark task for every shard. And so that means if you have 10 shards, you can actually start to read data out of Solr in parallel from each of the 10 shards at the same time. And then that's obviously spread around your Spark cluster. So you actually end up being able to read a lot of data out of Solr very, very quickly. And I've done some benchmarks in the tool set here that I'll point you to at the end of the talk, has samples of doing full table scans of millions of rows in like Amazon and those kind of things. So that's kind of the default built-in parallelism. One of the things that can be a little bit limiting in the sense that you only have 10 shards, but you have this huge Spark cluster. You only get 10 tasks, computing or querying into the Solr shards by themselves. So you're probably really not utilizing as much of Solr and you're definitely not utilizing as much of your Spark cluster as you could. So actually the Solr RDD allows you to specify an additional field, and that was this last bullet point, where we can actually do a split and use a range filter in Solr to then do deep paging based on splits around this range filter in each shard. So if you have 10 shards and you want to do 10 splits per shard, you can get 100 concurrent Spark tasks. So there's some stuff built in for that as well. So a lot of this wonky stuff, again, you as a user don't really care about, but at the end of the day, under the covers, this Solr RDD implementation is trying to be as efficient as possible. One of the other cool things, and I think this is a nice aspect of Spark, is that you can fire up a shell and immediately start executing commands in Spark. And so this is an example of that. Again, I'll point you to a GitHub link of the open source project that we host at Lucidworks that will actually build all this Solr RDD stuff into a jar. You can add that to the Spark shell here, and then immediately you can start loading in this code we just looked at a little while ago, so it's about the same. You load that into the shell, and you can immediately just start working with your Solr data from SQL. Again, the point is you can also load in a Hive data source and start to join data with Solr and Hive or a relational database or what have you. One of the things I didn't mention, but I think is noteworthy here, is that you can obviously do SQL, as we see there, and I apologize, that's about as complex as MySQL gets. I'm obviously a search engine developer, so I'm all about denormalization and Lucene's query API versus SQL. But you can also use, and I mentioned the data frame is a DSL for doing data manipulation. So you don't have to do SQL. You can do things like you see in that bottom example, where I'm filtering posts, and then I'm grouping those by the author ID and counting that, and then I'm doing sort of a descending sort on the count and limiting 10. So that's sort of a ornery way, I guess, of doing a facet on the authors with the most posts using the DSL here for data frames. But that gives you an idea that there's a really powerful sort of data manipulation language behind the scenes built into data frames in Spark. And so again, by us exposing Solr as a data frame, and then that's done through the DataSource API, you now have a very powerful language to actually work with Solr as well as other data sources. Okay, so that's sort of the read side of working with Solr from Spark. I want to talk about a little bit now more the write side. And one of the more common use cases that I've seen in the field is actually using streaming technologies. And there are others out there. There's Flink now, which is showing some promise. And then there's also Storm, which has probably been around the longest. We actually also have a Storm project that I built for integrating with Solr. But you can also use streaming in Spark. And the idea there is that you're bringing data in real time, potentially enriching it, doing ETL-type processes, and then hopefully you're sending that on into Solr, or actually you can even send it to Fusion using this framework. And that's a very common use case, is to sort of populate a search index with enriched data in near real time, right? And so Spark Streaming provides a very powerful tool for that, because again, they're going for that unified data processing platform for big data. And rather than you have to have Storm and Spark, they want to have a streaming solution for Spark. The kicker, though, with Spark is that they've taken the approach, well, the RDD is the essential data structure in Spark, and there's a lot of framework built around RDDs, especially around that fault tolerance, as well as shooting the most efficient way to do a transformation on an RDD. So what Spark Streaming does is it actually transforms a stream of records flowing into these small, deterministic, discretized, basically, sequence of RDDs. And so what that implies is that there's essentially a time cutoff, right? And maybe a second is a good RDD frame of reference, so to speak. So you can imagine how many tweets flow in every second, several thousand or what have you. So every second you would basically have a new RDD. And again, that gets partitioned around your cluster. So it's not like that RDD in 1 second is all on one node. That's spread around the cluster. But it's processed as an RDD. So the idea behind Spark Streaming is that once you have this RDD identified, now you can do all the things we've just been talking about around RDDs. So let's walk through a quick example. And again, this is the open source project I'll refer to at the end here has this built in, so you can kick the tires on this. And it shows actually quite nice example of how to take data from Twitter and get it into Solr very quickly. And you can do various enrichments. But the idea here is that you actually have a job, right? And we build into the Spark framework that we provide as a little Spark app to save you some boilerplate code and that sort of things. And you just submit this job using Spark submit tool. And you give some parameters. In this case, you're going to go Twitter to Solr, Zookeeper, and which collection to index into. All these things should look very familiar with you. What that does is out of the box, Spark comes with built-in tools to read from Twitter. And so it'll start streaming tweets in, and then you can do various transformations. And those are up to you. A common one might be language detection. Another one would be sentiment analysis, which is actually very hard on tweets, but some people have tried it. I think I tried it a few years ago. And then finally, you want to actually do some work to transform that data into what you want to index into Solr and then send it on into Solr. So I'll kind of color code it here. The key here is that the work of sending a stream of documents into Solr, we make that very easy in this. So you're in charge of what transformations you want to apply. And I'll talk about in a few minutes our Fusion solution, which allows you to do a lot of these various transformations and enrichments in pipelines. But whatever you want to do your tweets, eventually they need to be sent to Solr. The framework itself makes that very, very easy to do. This slide, I think, is actually intended just to show you kind of what the code looks like. Excuse me. And the code here, you can see, for the most part, is quite simple. You read in some tweets using this Twitter utils. You map the tweets into a Solr input document, and then you send it on to Solr. And we do the heavy lifting of actually making sure the tweets go to the right place in Solr. And by heavy lifting, there's code like this in this framework that we provide. I provide this so you kind of get a sense of how ugly it is actually behind the scenes to efficiently with Spark. That's not too ugly, but it's a little bit ugly because it's Java and not Scala. But I think the point here is that there's actually a lot of code that you don't have to worry about that we've taken care of as far as working with Solr. The last thing I kind of want to talk about is you can, as you're partitioning, say tweets are flowing in, you can use this concept of like a custom partitioner to decide where documents are routed inside of the Spark cluster. And we're providing, and continuing to sort of flush this out, but we're providing this shard partitioner so that you can actually directly send all of the docs that are intended for the same shard leader through the same task. And that ends up allowing us to use some built-in efficiencies in Solr, such as the concurrent update Solr client, which is a streaming technique, and it's extremely fast to index into Solr that way. So we provide some tools like this for really optimizing the performance of the indexing through Spark. Okay, so that's sort of, at this point, we've talked a little bit about using the DataSource API to read data out of Spark, out of Solr into Spark and manipulate it as a data frame, and then also being able to use do indexing into into Solr from Spark using Spark streaming. Or you can actually also just use the DataSource API because again, a data frame has schema. You can write a data frame to Solr, and we leverage that information, the schema information in the data frame to go ahead and write it into Solr correctly. So DataSource API is very powerful. I wanted to mention a little bit about Lucidworks Fusion because one of the more power users of Spark at Lucidworks and the Solr RDD framework and all that is actually our Fusion platform. And so this is a good architecture of our Fusion app platform. I'm going to talk a little bit about sort of the signal processing aspect you see there in the bottom middle. And so behind the scenes, One of the things that's very powerful about Fusion is that it's intended to help you close the loop on what we call signals. And this is, as people use your search engine, they leave effectively this evidence of their experience and their needs. They leave that as sort of log entries. They clicked here, they searched for this term, and then they clicked on the third result down in the results and that kind of thing. So as that builds up over time, again, this user-generated content becomes a data set that you can mine for more intelligence in your app. And Fusion is actually built engine, an aggregation engine that can scale up to very large scale using Spark to essentially close that feedback loop. So over time, you probably have, again, some of our users have millions of queries a day from their users. Well, we keep track of all that activity. Over time, patterns start to emerge. For example, people are searching for a particular key term and clicking on the third doc listed. Well, maybe that doc should be promoted to be the first doc listed because for whatever reason, it's more relevant to that search term. So that's the kind of click signals and things like that. To tease out that intelligence in our engine, especially at very large scale that we're dealing with, requires some distributed computation. And under the covers, we use Spark. The other area is sort of this idea of recommending based on other users like you also like blah. Right? That sort of collaborative filtering type machine learning based recommendation engine also provided by Fusion. Again, that's sort of heavy lifting at scale, and we use Spark for that as well. So one of the key takeaways from this in my mind is that if you have Spark or you want to start to use Spark to do large scale distributed computation, Fusion is a great place to start because it has the certified built-in Solr integration with Spark. And so I think that, and it also has a lot of things built in to make it very easy. So definitely encourage you to use that if you have interest in working with Spark and Solr. I won't spend too much time. I want to leave time for questions, but a couple of other things that I mentioned that we put into this, usually for just some specific use cases. But one of them is like Solr can store your term vectors for each document actually in the index. And a lot of the machine learning stuff in Spark, such as clustering, if you want to do a k-means cluster or whatever, you actually need term vectors. So instead of pulling out the documents, you can actually, with this framework, the Spark Solr framework, you can bring back the term vectors and immediately train a model or whatever in MLlib. So it helps you with that type of thing. Another one we have in there is sort of the idea of search on its head, or reverse search, is where documents flowing through the workflow, such as maybe like through a Spark streaming application, you want to match that document to a set of known stored queries, right? And then you could be doing that for alerts or matching against specific campaigns you're running or whatever. So the idea there is as docs flow through, you have this set of queries you want to match against that document. And so this makes it very efficient to actually index that document in an in-memory Solr. The key there is you actually still want to do all of your text analysis that you do normally. And so the document matching engine goes ahead and goes into Zookeeper and pulls out the right Solr configuration to use, indexes the document, and then executes the queries. And then, of course, that's sort of expensive per document. But if you have a Spark cluster, you can scale that up very nicely with Spark. So here's sort of just a rendering of what I just described. Imagine, again, our Twitter example, and as tweets flow through, we want to match them against a set of queries. And then the way we do that is we actually build an embedded Solr server that's seeded in configs or in Zookeeper. So again, that's a good way to distribute Solr configs. And then we match the documents coming in. And this is actually one area where I think the RDD approach of streaming works quite well is that because you have an RDD and not just individual docs, you have multiple docs usually grouped together. Again, the idea there was like every second, how many tweets every second are in my RDD. So now I can index multiple documents and execute my stored queries against multiple documents. So it actually scales quite well. And as I mentioned, Spark is intended for you to actually scale up and do a lot of heavy lifting around the Spark cluster. Okay, so to get started, I'll point you out to this GitHub address. You could probably just search Google for Spark Solr, and this will come up. It's a public open source project maintained by me and some of the my other colleagues here at Lucidworks. You just build it, and then I recently did a blog that'll actually help you get started working with the Spark SQL. Solr is a Spark SQL DataSource. And following that blog along is probably the best way to get started looking at the code. Again, and if you have any questions, please put them in the chat. I also want to mention that Fusion is available for download and to try it out. And again, that comes with Spark pre-integrated. And so it's a good example of actually using all of what we talked about today to do large-scale distributed computations using Spark and Solr. So that's all I have. I guess I'll turn it over to Andy for questions.
Thanks, Tim. Andy's actually helping me filter the questions, but I will be asking them. So everyone, we will now begin the Q&A portion of the session. Again, we have a lot of questions, so if we don't have time to get to your question today, someone from Lucidworks will contact you directly. So Tim, the first question for you is, can you please clarify what Spark running on Hadoop means?
Sure, that's a good question. So Spark running on Hadoop, I think that would be, that could be kind of two things. One is, as I mentioned, Spark treats HDFS as a sort of first-class citizen. So I guess Spark on Hadoop there could be just you're using Spark to compute, using Spark to compute using data in HDFS and then maybe writing to HDFS. And the other example there would be Spark comes with its own master sort of slave distributed cluster management, but it also works with Yarn. So a lot of the Hadoop distributions, and my guess is all of them at this point, talking Cloudera, Hortonworks, MapR, etc., will come with Spark. So you can essentially use the Yarn command line to start Spark as a Yarn app, provision it across your cluster, and then you'll use essentially Spark tools. Once that's provisioned, you'll use the Spark submit that I showed in my streaming slide to actually submit jobs to the Spark master that was provisioned by Yarn. So there's probably two different ways you can do it. I'd say the more common one I've seen, I guess, is to actually go ahead and use, especially if you're using a distribution from Cloudera or Hortonworks, is to actually use it from Yarn. I think that's it. Okay. Yep. Great.
So the next question, if I use Spark to analyze data, which database is the best choice?
I definitely have to say Solr. No, it really depends on your use case. I'd say that's sort of a vague thing, but it depends on your use case. One thing that, and really what prompted and motivated the development of this project for Lucidworks is that more and more we are seeing mission critical data in Solr, and so people wanting to access that mission critical data to do deeper analytics from something like Spark and then mix it with other data maybe in their warehouse and Hive is what really prompted this. But unfortunately I can't give you like specifics unless I knew your use case. But you have my contact information there. If you want to follow up or whatever, that would be great.
Thank you. Do you recommend using the Spark system to address joining documents in Solr? I want to join a doc in one core to a doc in another core.
So that's a tricky one as well because Solr has its own built-in sort of join technology, and there's actually more work going on there right now with some of the I don't know the ticket numbers off my head, but there's some join work going on right now. Solr joins, however, are more like sub-selects in SQL in the sense that you can filter results in one core with another. That being said, you can actually use this too, as you sort of allude. Let me step back for a second. If you want to do joins in Solr, cross-core, cross-collection, there's certain limitations on doing that, and I won't get on that because I know we have a lot of questions. But that's a limited tool set for you in Solr. If you want to actually join data and do some interactive data analytics, then you actually very much can load. If you remember, when I created a data frame, I set the collection name. So you could set two different collection names and have two different data frames, and then do true joins where you're actually creating, projections of data from both collections into one. And so that type of true join that you would do like a SQL, that is definitely possible by just having two different data frames all loaded from Solr and then computing them in Spark, right? And then again, the idea there is that you actually are using the power of Spark, and as I mentioned, that shuffle layer that's highly optimized to do joining, because typically when you're doing joining, you actually are at times going across the network and doing shuffles. And so that you can definitely use Spark to join data from two different Solr collections. So I think it's a valid use case.
Thank you. Next question. You mentioned RDD provides fault tolerance via replayability. Does this still hold if the source data is undergoing changes? For example, new tweets coming in.
Okay, yeah. So, and I didn't want to get into this as much because that's sort of in the Spark layer. But when data is coming in, that source data, that receiver has the idea of, and this is the implementation of the Twitter or whatever, but Spark has this idea of the storage, if you will, how to store that data that's coming in through the receiver. And so you can actually control that. Like if you don't want to lose a tweet, you can control that at the receiver layer and say, store these. And so that if I have to replay, you can go back and it's stored. Typically Spark will flush that out to disk and those kind of things. I'm not as familiar with like the cleanup of that, to be honest with you, but you can definitely control and say, I need this stuff to be stored, and Spark will store it. And so that if you lost a partition, such as I did in my example, Spark can actually go back and find that source stored RDD and then replay it from there. So definitely you have control of that as the developer when you work with the specific receiver.
Great. Next question. I see that Solr RDD is a Java RDD. Does it work well in Scala code?
Yeah, so a couple things about that. First is the DataSource API actually makes that less and less of an issue. As I mentioned, you could even use R or Python. One of the powerful things about Spark SQL, and it's a little bit of a misnomer that it's called Spark SQL, because really what it is a optimization engine for working with these data frames or these data sources. So absolutely, you can load, and I gave examples of the, loading up. This is Scala right here, right? So the fact that Java is a little bit in the mix, it's not that big of a deal, and obviously, Scala is on Java anyway, or it's on bytecode. But the point is, you as a Scala developer, if you use the DataSource API and you can read data and write data now through the data frame, then you don't really have to worry about the fact that the Solr RDD is implemented in Java, because you just work with the DataSource API as you see here.
Thank you. So the next question is, We are using HBase for core processing, so integration with HBase, Spark, and Solr will be of interest. Can you please talk a bit about HBase Spark integration?
Sure. So again, HBase and Spark, I mean, the bottom line there is you'll probably have, if one doesn't exist already, we'll need an HBase data source. And being a data source essentially means a couple things. On the read side, it means implementing interfaces that are defined by Spark for doing table scans, a very thing that's quite natural in the HBase world, and as well as doing scans with filters, right? And my example here, I'm doing a filter provider ask equals Twitter. Well, that in Solr turns into a filter query on the query that backs this Solr RDD. But in the HBase world, right, the data source itself is implemented in terms of HBase and can actually, I can't speak to HBase specifically, but things like pushing a filter down into the paths that are selected for reading on a table scan, that's very common in the Hive world. For example, my data partitioning scheme is around time, and I want to do a filter in my RDD filter around a specific date range, that can get pushed down all the way into the Hive layer to bring in just those, and just look at those specific HDFS blocks or those paths in HDFS. So I imagine HBase, if there isn't a data source, I imagine there's one probably in the works or coming. I'm not the biggest HBase expert, but I would look for HBase data source. And then again, it becomes, as I mentioned, now you have a data frame that's intelligently written for accessing data in HBase. And again, data frames also support write, or they can optionally support the ability to write. So you can essentially read data from Solr, change it, do whatever you want, and then write it out to HBase or vice versa. So really what you'd be looking for is a data source for HBase.
Great. We have another HBase-related question. Are there performance considerations when using Solr instead of the local HDFS or HBase?
So I think that again can kind of sort of be use case specific. I would say that one of the things Solr has going for it, which is very powerful, is the ability to execute very complex ad hoc queries. Systems like Cassandra are getting better, and HBase and things like that. But the bottom line is, I think Solr really is powerful about executing complex ad hoc queries. So if you're going to do a table scan out of Solr, and that's your only use case, Solr is probably not the best technology for doing large table scans off of, to bring data into Spark, because the inverted index structure behind the scenes just doesn't lend itself to that type of access pattern. Solr is all about optimizing ad hoc queries and those type of things. So it really, if you're going to compare HBase and Solr on the table scan level, HBase is going to win. If you compare HBase and Solr on the ad hoc query, I want to sit down at the Spark command line and do interactive data mining as a data scientist or whatever, Solr is probably going to win on that front. So again, it's sort of your specific use cases and kind of your access patterns. A lot of these NoSQL technologies are really optimized around one access pattern or another. And so if you try to mix and match those, you'll always get in trouble. And Spark's not going to sort of hide that from you, right? It's again, you have to decide what is the access pattern you want for your data, for the most part.
Great. So this will be our last question. Can Spark read from syslog streaming, or what other types of streaming can Spark read?
Yeah, that's a good question. So the Spark streaming, it's the platform for supporting this. And on the source side, it defines an API and a little framework for building what's called a receiver. And I think I might have showed that somewhere here. Yeah, so the Twitter stuff is a Java receiver input dstream. Dstream is just basically a discretized stream, right? That's your stream of RDDs. And so if there's not an implementation for your specific source, then it's actually quite easy to write one, right? And so I'd imagine for something like a logging or whatever, like a syslog, you could probably find something sort of already pre-built in the Netty package and then adapting it to Solr or whatever, or I'm sorry, not to Solr, but to Spark's receiver API would be quite easy. So I would start there looking at various receivers. There are a lot of them out there, around Kafka and all the different ways to get data. The other way, also, obviously, is Spark, as I mentioned time and again, is very powerful at reading HDFS. So if you don't need streaming, you can always just point Spark at HDFS directories, and it does a good job of reading those. But if you actually need streaming, go ahead and look at the receivers and look for, as you mentioned, a syslog receiver or whatever. But you could probably put one together yourself quite quickly as well.
Thank you. So we are now out of time. Again, if we did not have time to get to your question today, someone from Lucidworks will reach out to you directly. And everyone who registered for this webinar will receive a link to both the recording and the slide deck in the next few days. So if you have any questions, you can contact Tim, or you can go to the Lucidworks website and contact sales. And thanks again for joining us today.